Hi, this is Dr. Himayatullah Khan, and I welcome you to my video on Johansen co-integration test and vector error correction mechanism. Before I discuss Johansen co-integration test and VECM in greater detail, let us suppose I have four variables, and these four variables are consumer price index, industrial production, money supply, and treasury bill. First of all, I will check stationarity of all these variables, and suppose all these variables are non-stationary at level, but they become stationary by taking their first difference. So it means that when I take first difference of these time series, then these variables become stationary, and they are stationary if they are stationary of the same order, then I can test for Johansen co-integration and vector error correction mechanism or VAR model. Now the criteria is, if there is co-integration, I mean if there is long run relationship among these variables, then I will estimate vector error correction mechanism. But if there is no co-integration among these variables, then in that case I will estimate VAR system. So let me first of all open my file of variables. This is a EView file, work file data, and this is constant. This is consumer price index, one variable. This is another variable, IP, industrial production. This is my third variable, M1, that is money supply, and this is treasury bill. And in my previous videos I have checked their stationarity, and I found out that all these four variables were non-stationary at level, but they became stationary when I took the first difference, and all the four variables were stationary at their first level. So now I can do Johansen co-integration test. First of all, let me open all my variables as a group, and then I will test co-integration. So open them as a group, and this is the consumer price index, industrial production, money supply, and treasury bill. Now before doing any further analysis, I assume that all my four variables are stationary at the first difference, and this is time series data from 1960 January up to 2011 December. This is quite a big sample. So let me first of all go to quick, and then I will check group statistics, and under group statistics, I will go to Johansen co-integration test, and when this dialog box opens, it has all my four variables. So I will press OK, and when this dialog box comes, I should leave this, and this should be checked. This serial number 3 should be checked, and after pressing OK, it will estimate me Johansen co-integration test. Now these are the results of co-integration test, Johansen co-integration test. Now this small panel shows unrestricted co-integration test based on trace statistics, and this one basically shows maximum eigenvalues. Basically there are these two criterias, and I can reject or accept hypothesis of number of co-integrating equation on the basis of trace value or on the basis of maximum eigenvalues. Here this is null hypothesis, and the first one is that there is no co-integrating equation. Now if you look at this probability value, then we reject the assumption of no co-integrating equation, and then this is that at most there is no co-integrating equation. This one is also rejected on the basis of p-value, but regarding this we cannot reject this one on the basis of p-value, and three co-integrated equations are also rejected on the basis of this p-value. So the result of trace statistics indicates that there are two co-integrating equations at 5% level. Let me also confirm the same on the basis of the maximum eigenvalues, and this also is in conformity with the trace statistics result. And here also we see that maximum eigenvalues test indicates that there are two co-integrating equations at the 5% level. Now it means that there is a long run relationship among these variables, that is CPI, industrial production, money supply, and treasury bill. So what I will do after this, I will go to the top menu, and in top menu I will press quick, and under press quick I will go to estimate var. When I press this, I get this. So I will click this one. Since there is cointegration, so I will have to estimate error correction. If there were no cointegration equation, then I would have left this unrestricted var. So let me also write the four series here: CPI, IP, M1, and treasury bill, and let me press OK. When I press OK, so I get these results. Now these are vector error correction estimates, and this is the co-integrating equation, and these are the coefficients, these are the standard errors, and these are in the braces, these are the t statistics. Now here this is the error correction model, and there are four equations. This is a system of equations, but you see one thing, that when we check cointegration, we check them at level, but here when we estimate error correction mechanism, then automatically EUs convert these variables into the first difference. So I have a system of equation, four equation. This is the equation for the difference of consumer price index. This is its error correction. These are other coefficients for the leg 2 of all the two variables, all the other variables. This is industrial production, this is for money supply, and this is for treasury bill. Now you see all these coefficients have standard errors like this in parentheses, and in the third brackets they have t values, but there are no p values, so we need to have p values for them. And how can we do that? Now again, on this equation page, let me go to Prac and make a system, and then I will press order by variable. So this is my system of equation: equation number 1, equation number 2, equation number 3, and equation number 4. Now each equation has 10 coefficients, and there are 4 coefficients, 4 equations. So on the whole there are 40 coefficients, and you can see from here. So this is a system of equation. Now I will copy this. In order to get p values, I will copy this, and after copying I will go to quick again, and here, and I will click estimate equation, and in this dialog box I will paste, and after that I will press OK, and when I press OK, I get this, and this is my this is my model, vector error correction model for the first difference of consumer price index. This is the equation, these are the coefficients, and C1 is the coefficient of error correction mechanism. These are C2 is the C2 is the coefficient of industrial production in its leg, and C3 is the coefficient of money supply in its leg, and so on. Now, if you look at these p values, the vector error correction or the error correction coefficient must be negative, and it must be significant. And basically, this shows the speed of adjustment to the long run equilibrium relationship among these time series. It means that if there is any deviation from their long run associationship or long run equilibrium relationship, then there is error correction mechanism, and the sign should be negative, because it means that the system will go back, to the long run equilibrium. So this model has error correction coefficient of minus, and it is also significant. So it means that the system will converge to the long run relationship. I hope you could get an idea of how can we do Johansen co-integration test and error correction mechanism.